one, have you been practicing? Do you have lots of good proof practices or proof examples on here?
Yeah, I have a few that I've like struggled with a little bit. I did pretty. We had answer keys for our review guide today, so um, I got it pretty much all right. So
Oh, good. You just want to brush it up and make sure you've got it all correct.
yeah, and just like some stuff that we did, like I have, there's like one or two questions on the Jamboard that's like a few stuff that we did like a week ago that I just want to make sure I have.
Okay, sounds good. So given JH, is it congruent? Is that what you mean? JH and FG?
Yeah,
Or what's the question mark? Yeah,
it's congruent.
congruent. Okay, JH and FG. Okay, so these two are congruent.
Hmm.
That is congruent to that. Okay. K and M are midpoints.
Yeah.
Okay, so that means that these are equal to these, and this is equal to this. Now, I do know I can prove that those are actually equal to each other, and I believe it's the division property. Is that right?
Hold on.
I
Yeah.
want I want to say there's a property that says if two segments are congruent, then and you divide them equally or something, then the resulting segments are congruent or something like that.
Yeah, it's division.
Right. So that's going to be the
Yeah.
division property, but I'm not putting it here yet because we don't know that. They didn't tell us that. We can prove that, right, with the division
Yeah.
property.
Hmm.
And then it says HKF, HKF, HKF. This angle right here
Hmm.
is equal to FMH, FMH, this angle right here. Okay.
Uh-huh.
And KJG, KJG, this one right here. Let me change the color to make it a little bit easier to see. This one is congruent to MJG, MGJ. Okay. And what's it saying about JG and H and oh JGH, this one? Are they telling you that these are equal?
That they're it's JG each is congruent to FJG. Yeah.
FJG. Okay, so these, man, they're giving a lot of information,
Yeah.
right? They gave us that. And they want us to prove that the two triangles FJK, this triangle, is congruent to HGM, this one.
Mm-hmm.
Okay, so they want us to prove this one is congruent to this one, right?
Yep.
Okay, so game plan. Do we know the game plan?
Yeah, you like have to make those congruent. Yeah.
Mm-hmm. So what are we going to use to find things that are congruent? How can I prove that that is congruent to that? What was the one property that we just talked about?
Division.
Good. So you're going to cite the division property for that, right?
Yeah.
What else are we going to do?
Um, we can say that J um um JFG is congruent to JFK because um because they make a supplementary. No, never mind.
Okay, so you were
Um,
saying JFG. You're saying this big angle? Is that what you meant?
uh, no, yeah, no, I messed up there.
Okay, so I have an idea. How about this angle right here? and this angle up here.
Yeah.
And how am I going to show that those are equal to each other?
Supplement, if it's supplements of congruent angles are congruent.
Perfect. Exactly. So that I'm going to show that. And then I'll have side. I'm sorry. Then I'll have angle, side. And what about this one right here?
That one would be angle, another angle, but addition property or because
Yep.
bisects. Yeah.
It doesn't bisect it, but two congruent. See how I'm adding two congruent pieces? I believe that's
Okay.
the addition property. Can you read what the addition property says?
The addition property is if an angle is added to two congruent angles, then the sums are congruent. And if congruent angles are added to congruent angles, then the sums are congruent. I think
that's the one. That's the one. The second thing that you said.
Okay.
See how that's going to show us that those are equal. So then we'll have angle, side, angle. And then that will prove it. Okay?
Okay.
Sound good? For the
Yep.
sake of time, I'm not going to write it out, but
yeah, that's okay.
We have time at the end, maybe we can.
Yeah, it's fine. I'm writing this out anyways, so.
Okay. All right. Plan of attack for this one.
You have to like mark the diagram and then well no, it's already marked.
Kind of. It says that it's perpendicular, right? So
yeah.
what does it mean?
It just means that it like connects to form right angles.
Good. So we can state that these are both right angles, right?
Yeah.
We need to. Good.
Mm-hmm.
And then we can state that those are equal to each other, right?
Yeah.
Right? Because all right angles are equal. I think that's one of our properties. Right? And so what do we have? We have a side, angle, and what else do I need?
You could probably get a side or another side from reflexive.
Very good. Which one?
RL.
Perfect. And reflexive. So one of our formula or one of our reasons is going to say that, and it's going to say reflexive.
Yeah.
Yep. Good. And then what? So how do I know that those are equal to each other?
Because of a.
Say again.
Nope. SAS.
Perfect. Side, angle, side. Yep. And I always like to write side. I always like to write side, angle, side as I'm doing this. Right. Okay. So MO is congruent to MP. I'm sorry, OP. And that's given. Right. And then angle ROM is congruent to angle ROP. And that's because right angles are congruent.
Okay.
Right? Once you establish that those are both right. But do you see how you kind of set it up, side, angle, side, and then you can just boom, pop that right in there. Some teachers teach it that way and some teachers don't, but I kind of like that method of doing it.
Okay.
All right. Game plan. Page 3.
Fine. You could like draw a line between F and G, and then you'll have FDG and FEG.
Good. Okay. I like that. DF bisects. Okay. And EF. So can't I also say this? Definition of bisects, right?
Mm-hmm.
And we don't know that this is the same, so don't write one. Maybe do a double tick mark for that one, right?
Mm-hmm.
G is the midpoint of DE. Well, that means that this equals this, right? Definition of midpoint,
Yeah.
right?
Mm-hmm.
And then DF and EF are congruent. Ooh, that's nice that they gave us that. So these are congruent to each other. So close. So if only we knew that those angles were equal to each other. Oh, wait. Maybe we know that. CDE. Yeah. All right. So what's the plan? What are you going to do to say it? Have you
Um,
learned, some teachers are using 3.7 in their book and some teachers aren't. Did you go over 3.7, the if then? If sides then angles?
no. We just have like SSS.
Have you used that property yet? If you haven't,
We haven't used.
I
We
think in
haven't
your book it was
used.
3.7.
Yeah, we've only gotten to 3.4.
You haven't even gotten to chapter 4 yet?
We're on 3.4.
You're on
It's
3.4.
yeah.
Okay. But you haven't done if sides then angles or if angles then sides. You haven't done that yet.
No.
Okay. So let's see. How would we show um mm,
Could do FG is congruent to FG.
oh yeah. Yeah. You can, and then you can have side, right?
Yeah.
That's it. That's what you're gonna have to do. And then what when you have side?
Um, addition? Or no.
So yeah, so you're gonna have side, right? When you're gonna say FG is congruent to FG. Reflexive, you're gonna have FGD, triangle FGD is congruent to triangle FGE by side. And then you're gonna want to say that these two angles are equal to each other,
Okay.
right?
Oh, because corresponding parts of angles are.
Mm-hmm. Can you see that you're going to need to say that?
Yeah.
Because we didn't know that. So CPCTC. But now what are you going to say?
Then you can say that CDF and CEF are congruent because they're they are like because bisectors imply congruency.
So that's where I think maybe you want to use substitution.
Okay.
Maybe. Because you already said that that earlier you would have said that angle F CDF is congruent to angle FDG. And that's the definition of bisect. Right?
Mm-hmm.
And so now, let's see, can we use substitution?
Yeah.
So we know that CEF, let's see. Let's see, we just said that FDG, see FDG and FEG. And then you can substitute, like once you establish something, you can substitute one of them in for the other. But sometimes it's hard to know if you use substitution or if you use transitive property or if you use, what was the one you just said?
Multiplication.
No, you said something else. You said, no, you just like you used some property or some theorem. You read off some theorem.
CPTC.
No, it was like you said, I can't remember what you said, but I think you were reading it off out of your book somewhere.
Oh, was it addition?
Yeah, it might have been.
Yeah.
But see, that's the tricky part right there, is you're trying to show that, let's see, we've shown that these two are equal to each other. And now we want to use, let's see, what are they trying to get us to prove? CDE. See, they're trying to get us to prove this whole thing.
Okay.
So we just need to show that we know that these two are, we know these two are equal to each other. We just proved that by CPCTC. And that means, I think maybe it is the transitive property.
Okay.
If these two are equal to each other, then these two are equal to each other. Transitive and substitution are kind of tricky.
Yeah, it's transitive because if segments are congruent to the same segment, or if angles are congruent to the same angle, then they are congruent to each other.
Yeah. So I think it's the transitive property. This is congruent to this, and this is congruent to this. So this is congruent to this. But what I really want to say is that this is congruent to this. That's why I'm not sure if it's substitution or transitive, but I think transitive probably works fine.
Can't they both be the same thing?
Yeah, technically no, but sometimes you can use either one of them if you just word it correctly, if you're careful with how you label it.
All right.
But yeah, that's kind of a tricky one there.
Okay.
But then the last step you want to say is, because remember, we want CDE, we want this whole thing right here. Then you're going to do the addition property.
Okay.
The last step is the addition property. Okay, so step, do you see why?
It's like,
yeah, because you're gonna have to add a couple of them together. Addition property, because you showed that these are equal to each other now. So then the full thing is equal to each other. Okay. I believe that's what you're going to have to do. Again, there's probably more than one way to do this one. You probably could have done it in a different way, but I think that lots of steps for that one, because you want to just be really careful how you're doing it. Beyond the CPCTC, okay. Given AD and CD are congruent to each other, AD and CD are congruent to each other, and ADB, this angle, is congruent to CDB, this angle. They want you to prove that DB is the median to AC. Okay. So do you see the plan of attack for this one?
Kind of. Okay, so my issue is I can get to prove that the triangles are congruent. It's just I just can't get past that.
So you're going to use reflexive, and then you're going to use side angle side, right?
Yep.
And since they are congruent, then you want to prove that this right here is equal to that right there. And how can I prove
Okay.
that?
CP.
Mm-hmm. So AB is congruent to BC, and that's by CPCTC, right?
Mm-hmm.
And therefore, what would that mean if AB and BC are equal to each other?
And B is the or
Yep,
median.
yep. B is the midpoint. B is midpoint. And you can say definition of midpoint, right?
Mm-hmm.
And you can actually have just said that DB is the median. If you can say definition of median, I believe. Or you could
Okay.
break it into two steps. DB is median. Definition of median, I believe, right? What's the definition of the median again?
Let me find it.
It divides the segment into two equal parts or something like that.
Yeah, the proof for it is if a segment is divi- if a segment is diagonal, maybe that says, from the vertex of a triangle to the midpoint of the opposite side, then it is the median.
Got it. So we do want to say midpoint. We do want to say B is the midpoint. And then DB is the median, and then say definition of median, because the definition of the median said had the word midpoint in it.
Okay.
So I think it's probably safest to have both of these things here.
Okay.
You understand that?
Yeah.
Is that what you were struggling with?
Yeah, kind of. Yeah.
Kind of. Yeah, sometimes it's just a matter of like, am I writing it right? Am I, because you don't know if you're skipping a step or not, right?
Mm-hmm. Yeah. I do have one other question.
Mm-hmm.
My teacher like briefly mentioned this. She said it's not like a problem or anything, but just what's the no choice theorem?
The what?
No choice theorem. She like mentioned it and like we used it on like a few proofs. She said we won't use it much, but I just kind of like want to know what
No
it kind of means.
choice. Can you show me an example?
Um, hold
And I'll
on.
try to explain it, or I can look it up.
Let me see.
You want me to look it up real quick?
Sure.
On my screen, no choice theorem. No choice theorem. If two corresponding angles of one triangle are congruent to two corresponding angles of another, then the third angles are congruent. That's it.
Okay. I don't really get what that means.
So if you have two, basically what it's saying is if you have angle, then your third angle is also true.
Okay.
So if I told you that those angles are congruent and these angles are congruent, then there's no choice but to say that those have to be congruent.
If I can't find like the side of an angle or
So
another side, then can I use no choice?
say that one more time.
So like if I can't find the side of another angle or I can't prove that it's like that a side is congruent or another angle is congruent, then can I say no choice? Like that's the other angle is also congruent to prove that the
Well, if
triangles
you
are congruent.
here's what it basically means is if you have two angles are equal to each other, then the third angle, you also have three angles. But that doesn't mean that the triangles are congruent. Angle is not a triangle congruency reason. You need to have one side at least.
Okay.
So you get what I'm saying?
Yeah.
So the the no choice theorem. I'm trying to think of how what's an example of how you would use it. So do you see that theorem 54 in the upper right up here?
Yeah.
It's the correspondence between the vertices of two triangles such that two angles and a non-included side are congruent to the corresponding parts of the other, then the triangles are congruent. That's just angle. See, this is a side angle or angle side.
Mm-hmm. Okay, that makes sense.
I'm not sure why they call it no. I'm not sure what the reason for calling it no choice is. I mean, I understand what they're saying. I just don't get. Let me see if there's
Maybe.
Fifth way to prove triangles congruent. It must have two pairs of congruent corresponding angles and one pair of congruent sides. Yeah, you need a congruent side in order for it to happen. Oh wait, here we go. No choice theorem. Not a way to prove triangles congruent.
Okay.
Yeah, so this doesn't prove that they're congruent. This just, if two corresponding angles of one triangle are congruent to the third two corresponding, then the third angles are congruent. That's all they're saying, is that they're congruent. But that doesn't mean, unless you have a side, that doesn't mean that they are congruent triangles.
Okay.
Because angle does not make them congruent necessarily.
All right.
Right? Does that make sense? You need to have
Yeah.
a side because one of them could be small. They're similar. They're similar triangles, but they're not congruent.
Okay. Thank you.
Got it? They can be congruent, but until you have a side, until you prove that one of the sides are also congruent, then you don't know that the triangles are congruent. Okay.
Mm-hmm.
Hopefully that helps.
Yes. Thank you.
All right. Good luck with this.